Welcome everyone to another quick live stream here with latest AMD Ryzen 7000 series AM5 findings. So previous video got ourselves here this memory, right? This G.Skill and Corsair, and one is 5600, although previous video I never could clock it like that. This is the largest, like 64 gigs memory, which I would need. And then I got this faster 6000, which I could even nearly stable on first glance, probably not for YouTuber. But if you compile embarrassingly parallel LVM Clang Linux kernel, eventually you get some memory issues. But yeah, 6000, it advertised 6000, works 6000, nearly works 6200. The point of this video, of course, I said previously, I said I needed 64 gigs. And ideally 128. And I knew that AMD announced and officially specifies that if you run two modules, you get significant lower clocks. But I didn't expect it to be that bad, right? This is why I actually started reasonable with 64 gigs of memory. See, I was like, initially I was shocked how bad that clock, because not as rated. Then I was impressed how well the 6000 clocks, better than rated. And then of course I thought, yeah, actually I need 128, right? Previously, my previous overkill AM4 DDR for 1550X had already 96 gigs of memory. Why not just test that, right? Welcome to my last night's science experiment, and boy, did that go wrong. How to waste an hour or two and make your system a whole whopping of 30 seconds compiling the Linux kernel, or otherwise quite some percent slower with this trick. So what happens here, right? So AMD advertises, also this advertisement's here a little bit conservative, because they advertise here on AMD's official site for the 1750X. One module, one rank, 5200, one module dual rank, same, and then two modules, single or dual rank, 3600, right? So I was aware of that. I thought like, yeah, they're just super conservative. But yeah, unfortunately, I have to tell you that is a thing. So this screenshots from last night, as you see, yesterday, 2140, whatever. And I can't even clock those. So previously I could clock those 60 for 6000. And this rated 5600 is 5400. 54. So I combined, why did I waste probably 2 hours with this? It posts like forever, right? And usually fails. Also pro tip, because you're obviously here to learn something. Don't, like if you have some overclock and overvoltage, obviously disable that, right? Maybe even because I don't trust this shady BIOS code. Last year it burned memory channel with probably some of this auto voltage stuff from my 1550X. I would even, if you make such science experience or recycle modules, or you can't afford more, that's the only stuff you get and stuff, dial in fixed voltage to avoid the BIOS and AGESA and stuff overvolting your memory already, because one is 1.25 volt, the other is 1.35. Probably not that much of a difference, but you never know, whatever. So long story short, I tried various stuff, but so I booted now with 5400, if I recall correctly. I didn't make a new screenshot. Thankfully, usually DMID code. I know already from this that this is matching the BIOS. I think 5000, what did I say, 4400? Yeah, 4400 mega transfers. The voltage, however, is wrong, right? Do not believe all this DMID code BIOS provided tables, because you can already be lucky if the part number, the rank, or the speed even is correct, let alone obviously the voltage is off. So yeah, lesson learned today: when manufacturers advertise 1000, or so is it, yeah, more than 1500, so less clock, they really mean it. Even with 44 multiplier system memory, multiplier for memory frequency of I think this frequency is even theoretically is mega transfers, right? So the frequency should only be half of that. They probably write here frequencies for the gamers that they are not confused, but this is double data rate, so this mega transfers. I probably should write here mega transfers. So I can see, so yeah, that is the thing. And I also wonder two more things. So for me, that probably means I will probably, as nice as it was to be a week on the world's fastest, nearly fastest. They are faster, but fast 6000. It was a nice ride for 1 week, but obviously this level of performance sucks. I need more memory because embarrassing parallel compilation of LVM Clang, Rust, Firefox, Linux kernel, recurring theme here, right? So also I brought this locally, supporting a local business. So I can't as easily return that, and I need 64 gigs of memory anyway. So I will keep that one. I will probably return that one because this performance is meh. The performance might be a little bit better if you run the same module, right? I have here sample size 1, there's only so much thousands of euro I can spend here making a loss for this YouTube channel. There is no point for me keeping this memory right now. I need larger memory. That is of course a thing, like gamers don't need so much memory. So yeah, if you're gaming, then probably that is fine. For me, caching, more tempfs. Actually, I could build without tempfs, saving some memory. But that also costs performance. Anyway, if you run matching modules, this effect might not be as severe because this is also like 62 and then 96, and that is, oh, they don't print it here. I have it here. That is 77. So maybe this faster clockable memory just needs in general more TRAS. I wonder two more things. So theoretically it looks a little bit, I just didn't make enough screenshots. I probably forgot to make a screenshot of the memory timings or it saved somewhere else. It looks a little bit like you could set another voltage like here. There is this option for sync and program, but they don't do anything. So I've no idea what's this auto versus program, which I don't see any effect, like the recurring theme, previous videos, BIOS programming and UI and usability appear to be a never-ending pile of burning garbage. It looks to me like this is per module, right? We now have voltage regulators on the module, right? So I would think, should this not be per module programmable? Similar to, unfortunately, I didn't make a screenshot, but you probably know how it looks here with the memory timings. Similar, I wonder, couldn't AMD support different timings per channel to get a little bit more out of differently mixed modules? Again, the UI, yeah, I mean, probably the base clock needs to be the same, I guess, for syncing with the Infinity Fabric, but you have to wonder if they couldn't support different subtimings, at least, and voltages. Maybe that is a BIOS RGZ thing, and that is a recurring theme. Wouldn't it be amazing if this would be open source and we could, like, professionals could modify the BIOS to their liking and experience and stuff. So yeah, that's it for this video. So watch out what you are buying there. As per previous videos, and how much slower is it? So previous videos, I got here with like very fine-tuned, dialed in 6000 plus memory. I get here 25,000, right? So this is 300 geek bench points more. And yeah, granted, this Geekbench stuff highly fluctuates here. So one time I get even previously, so single core, I can't be that sure. I get here up to 2300, depending on the moon and overclock and stuff. Although I run right now with the same curve optimization, voltage and stuff. So I would guess the memory bandwidth with, although yeah, it's not in sync with the Infinity Fabric clock. It's not one-to-one clock there. But so yeah, otherwise I get here up to 2300, but even with perfectly dialed in 6000, I get here like one time 2100, one time 2300. It's a little bit mixed back here. But anyway, I hope you learned something, especially if you need lots of memory, like if you are a gamer or light programmer or stuff, or just a user who needs fast Firefox or Chrome and like tabs, then obviously it's easy, the easy decision of getting the fastest memory, of which is just 32 gigs of memory. But the crazy thing is even 64 gigs of memory, right? I just checked today, and like 10 days later, you still don't get much supply of faster than 5600. Lots of 64 gigabyte kits are only 5,200 and stuff, 5,400. So yeah, I dial this in. Maybe I spent another 30 minutes of trying to reach this. Maybe I give it a little bit more voltage or stuff. Now that I have a little bit more experience with AM5 and DDR5. Maybe give it a little bit more voltage, maybe a little bit less strict subtimings to reach 5,600. Maybe we are lucky with this one. And then I will probably use just 64 gigs of memory. Maybe I then don't build with TempFS. I have here also one of the fastest PC NVMe. PCIe, is it 5, 4, whatever, 6 gigs per second. Maybe I just ruin and wear level an SSD with all the builds. Theoretically, we could even in T2 apply like heuristics, like T2 our increasingly amazing Linux distribution with TempFS. I could actually create another setting, so we could either mark packages to be huge and not built in TempFS, or like obviously manual work is always annoying and the future is automation. We could simply, with a download table, right, automatically switch. If let's say, or you could even make this configurable, like why manually text stuff that is huge when the program, like our build scripts, can easily determine how huge it is. If we simply take the download files, and if the download files are like, let's say, more than 50 or whatever megabytes, so we would still build 90 or so % of all the small size in TempFS, and the embarrassingly large stuff is Qt, LVM, Clang, Linux kernel in not TempFS, just to optimize my use of CPU cores of embarrassingly parallel build, ARM and PowerPC and stuff in parallel. And that is a major reason I needed that much memory, right, TempFS. But obviously, and that is also another thing, not only you can obviously live and work and game with cheap stuff off of eBay, which I also recurrently do because I love this vintage hardware. You can also apply some common sense and brain cells on a problem and like not buy the latest and greatest because it's expensive and stuff, and simply optimize your software, which also open source, right? Amazing stuff, just optimize your software. Anyway, one last thing is like post times are long, right? I previously complained, so this easily posts a minute, which is annoying. That posted faster. I have the impression like the closer it is to the physical maximum. Alright, did I show you? I actually wanted to show you how this looks, right? My personal impression here from sample size 2 is the closer, because the 6000 posts, I think, a little bit faster. So also this is dual ring, right? So maybe it's like dual ring, or in general, the closer it is to the physical maximum and it needs to fine tune and rerun and retrain and stuff, the longer it takes. So I didn't stopwatch it, but easily a minute. This is maybe faster, maybe 30 seconds, which I still find too long, right? It's super annoying. You switch on your new build or stuff and it posts like, and you have a black screen, right? You don't know, will it post, will it burn a memory channel, will it explode, will it catch fire? But with this combined, the post time is easily freaking 2 minutes, right? Sometimes even 3, and then it fails. And yeah, so much to post times. And other people, I complained about 30 seconds, and other people like, yeah, you look at level 1 tech or whatever, like people complain about 2 minutes, right? Yeah, if you max that out, yes, I see you, 2 minutes, 3 minutes, it is crazy. And I also find it like another one last thing. I find it really low quality that the stuff goes in error. When the memory training fails, it has 80 or so megabyte of caches. Why can't the stuff present, like the BIOS, why can't the BIOS present itself with an UI instead of going into error? Like this engineering stuff, like computer scientists like do why? What are they thinking? They can display postcode but not run a BIOS on 80 megs of caches. Even if you say, okay, other Ryzen have only 40 or 36 megabyte of caches, it's like, is it not enough? Like directly mapped cache running, even a freaking Spark station can run without freaking memory from ROM. And display stuff on the serial console. So much to the futures now. But in any case, I mean, it should be possible, right? Just freaking implement it in the AMD AGESA. And otherwise, instead of displaying a postcode, it can really, instead of like giving up with, like still run with a like lowest base clock and like one last try, lowest base clock. It's really not rocket science. If I've probably shown this shortly earlier, so this is how it looks, right? If you're wondering why does this stuff not work and why does it not clock faster? So obviously the load, capacitive load and stuff, and signal integrity is degrades the more load you put on the traces of the PCI, which is also why you need to populate the outmost socket first, right? Which some people don't do, and sometimes even once I forgot. It's marked on this board and usually in the manual, right? Read the freaking manual. So for signal integrity reasons, like terminating this, not having open wires acting as an antenna and stuff, you need to populate the outmost socket first. And then probably the load becomes, like with two modules, the load also becomes higher and stuff. And then here with Tektronix DFE analysis software here for DDR5, all this ice here, degrading, like opening less and stuff. So this is how this looks on the wire. And if you ever wondered how the measure this, obviously probes and expensive logic analyzers and this are actually real scopes and logic. So this is not logic analyzers, these are real scopes. So yeah, if you memory vendor, that's how you probe that, and that is how it looks there on the traces, and why this is a fragile training stuff. And this is also why Apple can get away with higher performance, right? Because they don't have traces, right? It's on chip, so it's significantly higher clockable. Although, yeah, not user upgradable, right? Also significantly less power, right? Because you need way less power if you have this on chip stacked directly with fine interconnect than having, is it nearly 10 centimeters or whatever of traces, then obviously your signal integrity and stuff already goes so far. So yeah, that's for this video. I'm left here a little bit with a mixed bag. And another note is probably if you need that much memory today, you probably need to get a Ryzen Threadripper after all. Then probably AM5 is not really for you and me. I'm obviously running a little bit on the cheap end of using enthusiast prosumer hardware for my professional use cases. But then of course there's also higher single clock for Ryzen. But yeah, if you need that much memory, then obviously there is Threadripper and Epic, if just it weren't that expensive. But otherwise, I keep my eye out there. They eventually will be larger modules, right? I can't await that. But the problem remains, right? Even if you get larger modules, I think officially this board only supports 128, although I guess they eventually will be 164 gig modules. So probably, I think previously my X63 also only advertised 32 gigs memory, and I've run then 64. So yeah, eventually you will probably be able to run 256 gig on AM5, but don't quote me on that. Just a matter of these modules to become available, but then it's also a matter of clock, right? Then at which clock. And until then, there's Threadripper and Ryzen. I hope you learned something. And one last dash. Gigabyte BIOS is pretty annoying. Yeah, I mean, it's the Asus BIOS sucked. The Gigabyte BIOS is a little bit worse. I learned my lesson. Do they still hide SMT under advanced? Yeah, I mean, but this is the same with Asus, right? Probably this is the same with all. They all hide all this stuff in miscellaneous and whatever. Geekbench is too slow to check stability. Well, Geekbench was even possible to check stability because otherwise if it's not stable, you get spontaneous reboots or actually hangs, which is super freaking annoying. But also another thing, right? If this stuff goes into some, like my displays disappear, so it's like crashing like for real. I guess it's like system management BIOS firmware level thing because the Linux kernel is not under control anymore. Also, like the displays go black, so it's in some kind of reset state. But then on this Gigabyte BIOS, neither the reset button nor the power button work. I need to power cycle on the PSU, which obviously is also like you buy €600 board, and then if it crashes on the hardware level, then it's stuck in such a way that it needs a PSU power cycle, like seriously. And also, like, you can't run this unsupervised, right? If you run this as a compute node in your office and it crashes like this, it doesn't even freaking, why does it not freaking reboot, right? This is hilarious. And also, I really wish, if the stuff already detects a major system issue, I wonder what exactly, maybe on memory module, ECC or whatever. Not sure what exactly happened there. If you know what kind of strange state it is, because of all things I don't know in which kind of strange firmware Agesa crashed state it is stuck, that even the reset button doesn't work. I would really appreciate, like, I would rather get memory errors and like a proper signaling, like the Linux kernel can like shut down still, like clock down, shut down, that would be amazing. Instead of the system hang where you can do nothing. That is, but anyway, just some more 2 cents for me, and that's it for this video. Don't forget to share, like, and subscribe, and I hope you see you soon for the next fun stuff and talks and Linux programming to come.